Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we are going to look at feature selection. And these are the topics we are going to cover, which are different ways we can select important features from a data set to train a model. And so, why then? So, first of all, let's look at what is feature selections. Let's say we have a data set here on the left hand side, which has features from x1, x2, all the way up to x 100,000. So, from these 100,000 features, if we are interested in selecting only a few features that are important features, and we want to remove all the features that are not important to train a model, then that process is called feature selection. So let's say we apply feature selection and then we end up with just three features that are the most important features that are able to predict the value for y with reasonable accuracy. So here then the output of a feature selection would be these three features, let's say 99, 347, and 1000. All other features were deleted. So why is then feature selection important? One of the reasons is, as we talked earlier, is it can help improve the accuracy of a prediction model. The second is deciding on what features are important can help in making some business decisions. For example, if it's a transport company and you're trying to look at trying to minimize the cost or running cost for each of the vehicles, then uh, if miles per gallon for consumed by a vehicle would be important feature, so definitely want that. But then if there are other features, for example color of the vehicle or uh, color of the vehicle, so that definitely is not likely not going to affect the uh, mileage of that vehicle. So features such as those could be eliminated. And so from uh, let's say if you have 100 features and if you are trying to make some decision on improving or lowering the cost of the transport business, then you could say, okay, out of these 100 we now have these 10 features that are most important, and now we can now look into these 10 features for it. That can discuss within the company to see how things can be changed within those within those areas of improvement that are denoted by those 10 features that were shortlisted after feature selection. The another reason could be lowering computational cost. Uh, so if you have too many features, uh, if it improves the accuracy of a model marginally, and if you're okay with letting that marginal accuracy go at cost, letting that go by minimizing the number of features, then maybe you could reduce the computational cost. So uh, for processing or training that model, and simultaneously you could also reduce the training time and thus maybe expedite the process of training the models or expedite the data processing within a machine learning pipeline. And in Scikit-learn, there are different feature selection methods. Here we are not going to talk about PCA. Here we are going to talk about these methods that are available. The first one is variance based. So you can set a variance threshold, and if the value for variance for a feature is less than that value, then those features get dropped. Then we have these features using univariate statistics. We'll look at those now. There are recursive methods, and this is recursive feature elimination, RFE. Then select from model is another way you can select features, which has two main types, L1 norm based, and then tree based. And then in sequential feature selection, which is similar to recursive, but it's slightly different. In that also we can use the forward selection and backward selection. So variance, as just mentioned, the we can calculate the variance for each of the features and then have a preset threshold value for variance, and if the values drop below that threshold for any feature, then we can remove those features from the data set for further processing. For univariate feature selection, uh, these are the methods that are available. The first one is select k based and select percentile. So the first one selects top k features. So k could be any letter, it could have been n here. So selects top k features with the highest scores, and same thing for percentile. In the methods that are here in blue, those use the p values for deciding whether to keep or drop particular features. So there is select FPR, FDR, FWE, which is false positive rate, false discovery rate, and family wise error. And then there is generic univariate select, which can take any of these values to perform the selection. Now, as a warning, in while using these univariate methods, is what scoring function should you use. So as you can see, all these methods, even these three, calculate the scores, and you have the associated p-values. So if depending on whether if is it's regression or if it's classification, you want to use the appropriate methods that can be passed to these to perform the task of feature selection. So for regression, you there is F regression, and there is mutual info regression. So F regression calculates the correlation, F score, and p value. Mutual info regression is based on entropy using KNN. And then for classification, you have chi2, so that's the chi-square statistics. F classif, and that calculates the ANOVA analysis of variance and the F value. And then mutual info classif, it again calculates the entropy using KNN. So these are the scoring functions you want to use as an input for regression, these two, and for classification, these are the three that can be used when working with the univariate feature selection. If you swap them, then as I said in this warning, it could give results that do not mean anything. So recursive feature elimination, RFE, is this is kind of the flow of that. So let's say we start out with 100 features, we fit a model, we look at the feature importance for each of the models, then drop the features that have the least feature importance, and then check if after dropping the feature, have we reached the final number of features that we need. So let's say out of 100 we just need 3 features. We'll be iterating this. So the first iteration, now we still have many more loops to go, so you'll go back here and then run this through until you reach a selection of features where there are only 3 features, and those will be the selected features. Now the fit model. So here the estimators that can be used would be the supervised learning estimators that that have the attributes COEF underscore and feature underscore importance underscore. So either this or this, and whichever. So let's say if we have COEF coefficients, so those could be thought of as the weights. The higher the weight, the more the importance, and so the lower values would get dropped. Now, feature selection from a model is again similar to the earlier method, except that now here there's specification that L1 norm based models can be used or tree based models can be used. And again, the models can be fit. So here, the models can be either fitted or unfitted both, and again they should have the COEF underscore or feature importance attributes. Else, if it's not there, then the suggestion is to use the importance greater parameter while running the feature selection in this method. Again, if the calculate the feature importance and drop the features with low importance, iterate through this until the final desired number of features is reached, and then those are the selected features from total number of features. Next, this is sequential feature selection. First, we look at backward selection because it starts with all the features. So essentially, you start with all the features, fit a model, then calculate the cross-validation score, and then drop the features based on cross-validation score. So here there is no need for uh, no need for the coefficients or the values for feature importance. And so you start with all features, and then you narrow down to the features that are important, and then once the desired number of features is reached, so that's when you stop the iterations. And opposite of this is forward selection, where you start with 0 features and then add one feature in each iteration, uh, and look at the cross validation score. If the cross validation score improves, keep that feature. If it reduces, drop that feature, and continue this until your desired number of features is reached or you get the best cross validation score. And finally, feature selection can be used as part of pipeline, as shown here. This is just one example. You have a pipeline where the first step is doing a feature selection, here using the select from model method, and then performing the task of classification. So just put these two in a pipeline and then perform fit on X and Y. So it'll automatically go through all the steps within this pipeline, in this case feature selection, and then use those selected features only to perform the fit using the linear model rich classifier. And finally, for code snippet, this is where we have this data set, load iris, and we are using the select from model, which takes in the estimator. So here we are using linear SVC, and so you can fit that, and then you can look at the shape. You can use transform on X to look at the new dimensions of X after the less important features were dropped. So that was it for the intuition of how feature selection methods work in Scikit-learn. In the next video, we'll look at the implementation using toy datasets on how each of these work. Until then, please like, share, and subscribe. I hope to see you all in the next video. Thank you.